Let's look at the implementation of malloc. So make sure you include the header file. So pound include standardlib.h. So first n, comma I. I is used to index into the array. N will be used to enter the size of the array. And I need a pointer, which will point to the base address of the array. So printf, enter the size of the array. Scanf, read it from the user. Percentile d, comma, ampersand n. So at this stage, I can use my malloc function. So int star malloc n star size of int. Now here, there are two things that can happen. Let's assume that the user enters the size of the array as a negative number. In that case, you cannot have negative memory space, right? So, so we have to account for that. So we can write an if statement saying if pointer is less than or equals to 0, then I can say printf memory not allocated. And I can exit the function or exit the program. As I said, two things can happen. The user can enter a negative number or a 0 number. So this takes care of that part. If the user enters a positive number, we are well and good. So if the user enters a positive number, this if statement is going to return a false. So you're going to execute a statement starting from line 20. So I can say printf memory successfully allocated. Now, with malloc, all the values are going to be garbage. So assuming, let's say the user enters 5 here. So you're going to get an array of size 5, but all those 5 values are going to be garbage. So we can initialize it with something else. So I'm going to write for I equals to 0, I less than or equals to n minus 1, I plus plus, pointer of I equals, let's simply do I star 5. Then I can say printf array elements are for I equals 0, I less than or equals n minus 1, I plus plus. I can say printf percentile d, comma, pointer of I. So let's see what happens now. Run. Enter the size of the array. Let's say I enter -10. It says memory not allocated, program finished with exit code 1, which means this statement got executed. Let me enter a positive value. Let's say I enter +10. So I need 10 elements in my array. So it says memory successfully allocated. Array elements are, okay, I forgot to give a space. So let's run it again. So the array elements are 0, 5, 10, 15, 20, so on up to 45. So that's a total of 10 elements. So using dynamic memory allocation, you're able to ask the user to enter the size of the array. And then depending on that, you can initialize it with random values that you want. Now, I forgot to mention the free function. So the way you want to deallocate the memory is you can use free pointer. So that's the free function. So if you think that you don't need the array after this line of code or after this line of code, then you can free the array and then you can write some other logic or you can do some other operations. So these operations can utilize the memory which was freed earlier, and it can probably be much more efficient. It doesn't need to worry about resources, at least a little bit. So this is the concept of memory allocation. Now we can do the same thing with calloc. Let's make the change. So instead of malloc, I can write calloc. And instead of n star size of int, I just write n comma size of int. So it's going to do the exact same thing. So let's say 10 elements. So when you created this, assuming that n was given the correct value or a positive value, it can create an array with n as the size, and all those elements would have been zeros. So we were able to create this array here. We were able to put values into the array, which was I times 5, and we were able to display it and release the resources once we are done.